Part 2 of Section 4.5, Calculating Atomic Mass. Atomic mass is the weighted average of all the isotopes of an atom. It is reported on the periodic table below the element symbol. Remember, atomic mass is not the same as mass number. Mass number is strictly protons plus neutrons. So how do we calculate atomic mass? How is that number that is on the periodic table below the element symbol, how is that calculated? Well, there's a little formula here. Atomic mass is equal to the product of the first isotope's percent abundance times its mass, plus the second isotope's percent abundance times its mass, plus the third isotope's abundance times its mass. And if you had more than 3 isotopes, you would add additional terms for those. Okay? In Chem 110, we will only go up to 3 isotopes, but there are many elements that exist that are on the periodic table that are made up of many isotopes. Uranium has 7 different versions, 7 isotopes. That's just one example, okay? So we are going to do examples with 2 and 3 isotopes predominantly for Chem 110. Again, what is X? X is the decimal equivalent of the percent abundance of an isotope. Some isotopes exist in a higher abundance than others. Okay, some are more common than others and therefore have a higher percent abundance. So if something exists in 80% abundance, then we would write the decimal equivalent of 0.80, right? We'll do that when we do examples. So it's the decimal equivalent of the percent. 20%, decimal equivalent, 0.20, okay? M is the mass of the individual isotope in units of AMU. Very creatively called atomic mass units, AMU. Okay, so you'll be given certain information in the problem that you can use to solve for atomic mass, and then you can check against the periodic table to see that the calculation is done correctly. Let's do 2 examples, one where we have 2 isotopes and one where we have 3 isotopes. Okay, let's do a problem, calculating atomic mass. We're told that boron has 2 naturally occurring isotopes. Boron 10 has an abundance of 19.80% and a mass of 10.01 atomic mass units. Boron 11 has an abundance of 80.20% and 11.01 atomic mass units. We want to calculate the atomic mass of boron. Now there are 2 isotopes, but they're weighted differently. This one occurs 80% of the time in nature, and this one occurs a little less than 20% of the time in nature. Okay, so it's not like it's 50-50. It's not an average that is everything is weighted the same. They're weighted differently. We need to take that into consideration in doing the calculation. So atomic mass A. Okay, we have 2 isotopes, so we only need to have 2 terms. Okay, now what I always recommend, because from teaching this for quite some time, convert your percents into their equivalent decimals. Now I know that some of you may say, I'm good at math, I don't need to do that, I can do it in my head. Yes, you can, but from me teaching this, all the years I've been teaching it, I'm going to make this extra step as I always do. Convert the percents to their decimals. You may say there's a decimal there, but it's decimal equivalent. 19.80% is equal to 0.1980. You know the percents are out of 100. Percent, per cento, per 100. So you took this and divided it by 100, that's what you would get. Move the decimal 2 places to the left. 80.20% is equal to 0.8020 for a decimal equivalent. All right, now you can have everything to plug in and solve. First decimal, decimal equivalent 1980, 0.1980, times the mass that goes with that isotope, 10.01 AMU. Your second isotope has an 80% abundance. The decimal equivalent from this exact percentage, 0.8020, and you need to make sure you times it by the correct mass. Now, I recommend you do it in one step in your calculator, because what happens is if you do it separate, then you round. People tend to round and they don't get the best possible answer. So put it in your calculator in one step. Use the parentheses, Rive parentheses, open parentheses, 0.1980, multiply sign, 10.01, 10.01. Close the parenthesis. You can't put the unit in there. Close the parenthesis after you put this number in. Addition sign. Open parenthesis. 0.8020. Multiplication sign. 11.01. Close the parentheses. Okay. Equals 10.812 AMU. If we round it to 4 significant figures, because everything had 4 significant figures, 10.81 AMU. Look at your periodic table and look at boron. Find boron on the periodic table. Atomic number 5, symbol B. Look at it. What's the atomic mass reported on the periodic table? Oh, it's a little bit blurred. 10.81. Let's see if it's blurred on here. Might be able to see it better in the textbook. 10.81. Okay. So that's the way you can check. You can check against the periodic table. So we'll just write a third step, check against periodic table. Okay? The atomic mass is the weighted average of all the isotopes that exist for that element. Let's do another example where we have an element that has 3 isotopes. Calculation would be the same, except we would have a third term over here. Okay, so let's do one with 3 isotopes so that we have 2 good examples for a reference. Okay, let's do another example where we have an isotope that, where we have an element with 3 isotopes, excuse me. So, let me adjust this camera a little bit here. Sorry, it got a little bit knocked over. Sorry. Okay. Magnesium consists of 3 stable isotopes with the following percent abundances and masses. And we want to calculate the atomic mass of magnesium. Okay, well, we are given the 3 isotopes, magnesium 24, magnesium 25, magnesium 26, the relative masses of each individual isotope, and the percent abundance of each isotope. Okay. So what we could do first is convert the percents to their decimal equivalent. Okay, so 0.7899. 0.1000 and 0.1101. Okay, so we have the decimal equivalents for the percent abundances. All right, now we can set up our formula, X1M1 plus X2M2, and because we have a third term, because we have a third isotope, we have a third term there, okay? So let's keep together the decimal equivalent for the percent abundance with the mass of the individual isotope. So 0.7899 times 23.99 AMU, that's our first term for the first isotope. Add that to the product of 0.1000 times 24.99 AMU for our second isotope. And then we have our third isotope. I do not want to squish that down, so I'm going to write it below here. 0.1101 times 25.98 AMU. Okay, I'll put the plus here. All right. Okay, so now we need to get the final answer. As I did in the last example, and I'm going to do again, it's best to do it with one entry into the calculator. Okay, our final answer should be rounded to 4 significant figures because everything here has 4 significant figures and we have multiplication involved, so the lowest number would be 4 significant figures. Okay, open parenthesis, 0.7899, multiplication sign, 23.99, close the parenthesis. It's your first term. Add your second isotope. Open parenthesis after the plus sign. 0.1000 times 24.99. Close your parenthesis. Okay, so you have 2 terms. I don't know if you can see it when I hold it up there. Maybe my explaining it is clear. Then you need to put your third isotope term in. Plus, then open the parenthesis. 0.1101 times 25.98, close a parenthesis, then do enter. Okay, so you initially get this answer, 24.309. Okay, you get this non-terminating decimal. So we went around to 4 significant figures. So that would be 24.31 atomic mass units. All right, for 4 significant figures. And if you were to look at the periodic table for the atomic mass of magnesium to check, all right, magnesium right there, 24.31, okay? So this checks with the periodic table. Okay. All right. And that's how we calculate atomic mass, which is written on the periodic table below the element symbol. Remember, in the nuclear symbol, the isotope symbol, you have the mass number at the top. Remember, mass number and atomic mass are not the same. Okay, I just want to leave you with one little illustration, one little thing before we conclude out this chapter. Just want to make sure that you can freeze the video if you need to copy anything down before I erase it. Okay. Just to point out what I've been pointing out along in this video. This is the periodic table. This would be a nuclear or isotope symbol. Remember, atomic number is at the top on the periodic table. It's on the bottom left with the isotope symbol. The periodic table shows the atomic mass, which incorporates all of the isotopes. But then with the isotope symbol or the nuclear symbol, this is your mass number, which is the protons plus the neutrons. Okay, so I just want to make that distinction again. Okay, and this concludes chapter 4. Okay. As always, with any of the videos, any of the recommended homework problems, any questions you have, please reach out to me and we can converse through email, we can converse on the phone, through Zoom, whichever works best for you. Okay.